This video introduces CornerNet anchor-free object detectors. CornerNet is an anchor-free object detector that detects an object bounding box by using a pair of key points in heat map extracted by backbone network, namely the top left corner and the bottom right corner, without necessarily predefining a set of anchor boxes. Here, architecture and pipeline of a CornerNet network. As an input image, as a backbone, for example, hourglass network. Based on the feature maps extracted by using backbone to corner polling modules, top left and bottom right, are used to generate two groups of output, including heat maps, embedding, and offset of the corners. And then post-processing is used to find the final output. CornerNet uses two corner polling modules to detect the corners of objects in an image. The embedding vectors in latent space are applied to group corners as top left corner and bottom right corner that are used to describe a bounding box of an actual object. The offset are used to describe a mapping error caused by the output straight between the heat map and the input image. To determine if a pixel in a heat map is the top left corner, CornerNet looks horizontally from right to left for the leftmost boundary, as shown here, and vertically from bottom to top for the topmost boundary, as shown here. The two put results are combined to determine the top left corners. From this one and this one, we get the top left corners. And similarly generates the bottom right corners. CornerNet predicts two sets of heat maps, one for top left corners, one for bottom right corners. Each set of heat maps with a size h by w has C channels. C is the number of the object categories. Each channel is a binary mask, including locations of corners for a class. A 2D Gaussian kernel is used to describe a probability of a key point being the ground truth, which ensures intersection over a unit of a prediction and the ground truth at least 0.7. The focal loss of a bounding box corner detection is defined here, where P, C, Ij is a score at location Ij for class C in the heat maps, and YCij is a ground truth. N is number of the objects in an image, and alpha beta I parameters. When the locations are mapped from the heat maps back to the input image, some precision may be lost, which can largely affect IOU of small bounding boxes with their ground truths. The loss of location offsets are defined by smooth L1 function to adjust the corner locations, as here. Where OK is a predicted offset and OK hat is the actual offset. CornerNet predicts one set of offsets shared by the top left corners of all categories, and one set shared by the bottom right corners. There maybe exist multiple objects in an image, and therefore multi top left and the bottom right corners may be detected. CornerNet determines if a pair of top left corner and the bottom right corner come from the same bounding box, as shown here. Suppose that ETK is the embedding for the top left corner of object K, and EBK for the bottom right corner. CornerNet uses the pull loss to group the corners from the same object, and the push loss to separate the corners from a different object. For example, P1T and P1B are close to each other in latent space, while P1T is far away from P2B. The loss function is defined here, where EK is the average of ETK and EBK, and delta is selected to be 1 here. The loss is only applied at the ground truth corner location. The full training loss is defined as a sum of 4 losses, where alpha, beta, gamma are the weights for the pull, push, and offset loss, respectively. For more details, please check with these references. Thank you. Bye.